Alright, today we're going to use some visual models to add and subtract two fractions with the same units. And we are also going to use visual models to add and subtract two fractions with the same units. And then we're going to even throw in there subtracting from one whole. So the first thing we're going to open with is 5 ones minus 4 ones equals 1 1. So the standard 5 minus 4 equals 1. Now we go to a different set of units. 5 dogs minus 1, 2, 3, 4 dogs equals 1 dog. And if we go to meters, 5 meters minus 4 meters equals 1 meter. So see how the subtraction doesn't change, but the unit does? Well, let's keep going. 5 sixths minus 4 sixths equals 1 sixth. So it's still the standard 5 minus 4 equals 1. However, the unit is now sixths. Now let's show 5 sixths minus 4 sixths on a number line. So if we look at this number line, I've partitioned it between 0 and 1 whole, partitioned into sixths. That's a really tough word to say, sixths. Partitioned into sixths. Now let's find 5 sixths. 1, 2, 3, 4, 5. Right here is 5 sixths. Now let's count backwards 4 sixths. We're counting back 1 6, 2 6, 3 6, 4 6. So we're going to land right there. But since it's not marked, let's count backwards a little bit differently. Let's count from 5 6 to 4 6 to 3 6, 2 6 to 1 6. So 5 6 minus 4 6 equals 1 6. So there's our visual model, placing it in a number line, which you should be very comfortable with, and then counting back the number of sixths. Let's look at this one. 10 sixths minus 2 sixths. This one's just a little bit different. So we're going to look at this on a number line. So right here, we're going to have ourselves a handy-dandy number line drawn out from 0 to 1 and partitioned into 6. But what do you see as the problem here? If you see that 10 sixths is greater than 1 whole, then you see that problem. So I can't have a number line between 0 and 1. My number line needs to be from 0 to 2. So let's remake our number line. It's going to be a little bit longer. It's going to start at 0. It's going to go to 1. And it'll end at 2. Now partition into 6. See, since it's an even number, I started with partitioning it in half, and then I knew that 2 times 3 is 6, so I partitioned each half into thirds. So let's find 10 sixths. I have 1 6, 2 6, 3 6, or 1 half. 4 6, 5 6, 6 6. I'm going to keep with an improper fraction. 7 6, 8 6, 9 6, 10 6, right here. Now we're going to count back 2 6. We're going to take from 10 6 and we're going to go back to 9 6 and 8 6. So right here, the answer to our question is 8 sixths. Now what do you notice about 8 6? If you've noticed that it is greater than 1 whole, you're correct. So now we need to take our answer, 8/6, and we need to write it as a mixed number. We're going to do that using a number bond. So when we make a number bond for a fraction that is greater than 1 whole, we need to partition it first in 1 whole, then the leftovers. So when we have 6 as the denominator, how many sixths equal 1 whole? 6 sixths. Now, what's our leftovers? 6 sixths plus what equals 8 sixths? 6 plus 2 equals 8, and our denominator is 6. So writing this as a mixed number, how many wholes do we have here? How many 1 whole pieces do we have? We have 1 whole, and that's it. So we have 1 whole piece, and what is our leftover? 2 sixths. So this right here is our mixed number. So 8/6 equals 1 and 2 6. So far, so good. Now let's look at some addition of fractions. So here I have a number line partitioned from 0 to 1, and I've partitioned it into fifths. So let's find 1/5 on our number line. 1/5. Oh, that was pretty good. Now we are going to add 3/5 plus 3/5. So we have 1/5, 2/5, 3/5. So 1/5 plus 3/5 equals 4/5, or 1/5 plus 3/5 equals 4/5. Now, if you'll take a moment to notice this part right here. You should notice that we are dealing with like denominators or common denominators. And when you have common denominators, then you can just add or subtract the numerators. We have 2/8 plus 3/8 equals, I don't know yet. So we are going to make our number line. We notice that both of these fractions are less than 1 whole. We make our number line from 0 to 1. We have eighths, so we can partition in half. What times 1, 2 equals 8. We can partition each half into fourths. All right, so now I have a number line that's partitioned into 8. I need to find 2/8, 1/8, 2/8 right here. And from there I need to add 3/8. 1/8, 2/8, 3/8 right here. So where did I land? 1/8, 2/8, 3/8, 4/8, or 1/2, 5/8. Good, and see we have like denominators, 8 and 8. So we were just able to add 2 plus 3, and we got 5. Now this is a little bit different. So we notice from our fractions we have a 5/4 plus 2/4. So we notice that one of these fractions is greater than 1/2. However, we have like denominators. So I guess you could say it's not anything new to us. We use that information that one of them is greater than 1/2, and we're adding, so we need to partition this number line from 0 to 2. And our denominator is 4, so we need to partition each, we need to partition each half in half. So we have 1, 2, 3, 4. Now let's find on our number line 5/4. 1/4, 2/4, 3/4, 4/4, 5/4. Now we need to add 2/4. Add 1/4, 2/4. How many fourths is on this number line? Here we go. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. So looking at this, we have like denominators, 4 and 4. And if we were to add 5 plus 2, we get 7. And our denominator is 4. So 7/4 is our answer. However, it is an improper fraction. Therefore, we need to write that improper fraction of 7/4 as a mixed number. We'll break it up into a number bond. We have a fraction that's greater than 1/2. So while using a number bond, we first partition this into 1/2. How many fourths equals 1/2? 4/4 equals 1/2. And what's my leftover? So our like denominator is 4. 4 plus what equals 7? 4 plus 3. So we look at our number bond. How many 1/2 pieces do we have? We have 1 1/2. And that's it. So we have 1 1/2. And what's our leftover? 3/4. So in answer to our question, 5/4 plus 2/4 equals 7/4, which is 1 and 3/4. Now looking at the same idea, but this time we're going to take a whole number and we're going to subtract a fraction. Our whole number that we're going to start with is 1. So we're going to be subtracting from 1. Subtracting fractions from 1. The first thing we need to do is write this out as in fraction form. So we have 1 minus 3/8. So our denominator is 8. We need to ask ourselves, how many eighths is equivalent to 1? 1, in this case, equals 8/8. So now we can write this as 8/8 minus 3/8 equals what? If we were to draw our number line, we know that we're starting with 1 and we're moving backwards. So let's make a number line from 0 to 1. Go ahead and partition that into eighths. And we're going to start with 8/8, or 1 whole. And we are going to subtract 3/8. We're going to go back 3 times. We're starting with 8/8, 7/8, 6/8, 5/8. We went back 1, 2, 3 times. So in answer to the question, 8/8 minus 3/8, we notice that we are dealing with like denominators. So the question really is 8 minus 3 equals 5, and our denominator was 8, or 8/8, 1 whole, minus 3/8, 1, 2, 3/8, equals 5/8. Now we're looking a little algebraic here. 1 minus what equals 2/3. So every time you see x, it's really asking you 1 minus what equals 2/3. So in a number bond form, we start with 1, and we know 2/3, but 2/3 plus what equals 1? Well, in this particular case, since our denominator is 3, 1 equals 3/3. Now we can ask ourselves, 2/3 plus what equals 3/3, or 2 plus what equals 3? 2 plus 1. So here we have 1, which would equal 3/3, minus what equals 2/3. So obviously we're dealing with like denominators. So here we can already fill that in. We're dealing with a like denominator. So the question is, since they're like, 3 minus what equals 2? 3 minus 1. So in this case, x equals 1/3. Because the question here isn't what it equals, it's what is x. It's like a puzzle. X equals 1/3. So here we have the same idea. We have to find out what x equals. So here we have 2/5 plus what equals 6/5. Well, obviously we're dealing with like denominators, so that's good. Means that we can already fill in that it's something fifths. Now we just need to ask ourselves, 2 plus what equals 6? 2 plus 4. So x equals 4/5. Now, since we are fraction people, we can't just let 6/5 be. 6/5, we need to write that as a mixed number. We notice that 6/5 is greater than 1 whole. So here we should make a number bond. 6/5. We know it's greater than 1 whole. We're dealing with a fraction that's greater than 1 whole, so the first partition should be what is 1 whole? 5/5. Now the question is, since we're dealing with like denominators, fifths, 5 plus what equals 6? 5 plus 1. how many one-whole pieces do we have here? We have one whole, and that's it. We have one whole, and what's our leftover? 1/5. So 6/5 equals, as a mixed number, 1 and 1/5. That is today's lesson, and I think it will go pretty well if we just remember that it's nothing fancier than just changing a unit. Dogs, meters, sixths. Remember that when you are dealing with, where's a good example? When you're dealing with like denominators, then you simply add the numerators.